Alright, so again, one last time here, story problem. For shipping purposes, we need to create a box with a square bottom and a volume of 184 inches cubed. What dimensions should it have so that we minimize the surface area, and then what is that minimum surface area? So that's our situation, okay? Our job is to figure out that minimum surface area, or what size to make the box, so it still has this volume, but a minimum surface area possible, okay? So the first thing I would recommend doing, you don't have to do this, alright, but if I were doing this problem, I would probably draw a picture of a three-dimensional box, okay? So I'm going to draw a picture. Draw a picture of a box. Draw a picture of a box. I know the bottom of the box has to be a square, so in other words, I know both of these have to be the same length, you know, 1 by 1, 2 by 2, 3 by 3. I know the bottom of the box has to be a square, that's what it said in the problem, and then I don't know what the height would be, so I would probably just call this H right here. Okay, so the bottom of the box has to be a square, so I labeled both of those with an X, and then the height has to be H. Okay, that's kind of how I would start this sort of problem. Then we're going to work with both the volume and the surface area formulas for a box, which you should be able to either figure out or know. Okay. First of all, anytime you do the volume of a box, anytime you do the volume of a rectangular prism, volume equals what times what times what? Length times width times height, right? Okay. Question?
Do we need to memorize these?
Yes. Yep, absolutely. All I'm giving you is that first slide, okay? Ready? I'll give you that first slide. You got to be able to roll from there. Okay, so the volume of this box would be x times h, or in other words, x squared h. X times h, x times x is x squared times h, so the volume of the box is x squared h. Okay, and surface area, there's really no memorizing surface area formulas. Okay, how do you do the surface area of anything? Add up all the surfaces, right? Find the area of this surface, plus the area of this surface, plus the area of this surface. There's no formula. Well, there's a formula, but why would you memorize 18 million formulas? Okay? Know how to find the area of a rectangle, find the areas of all the rectangles, and add them together. Okay? Saves yourself the time from memorizing. Okay? So, we got to add the area of all the surfaces together. Okay, well, the bottom of the box. What's the area of the bottom of the box?
Base times width.
So in this case, though, x times x, right? Which would be x squared. So the area of the bottom of the box is x squared. What's the area of the top? So I got x squared here, I got an x squared here. Alright? How about this side? xh. The area of this side is x times h, or xh. How about the other side? xh. How about the front? And the back? So x squared plus xh plus xh plus xh plus xh, or really 2x squared plus 4xh. Right? So the surface area of the box would be 2x squared plus 4xh. Questions?
Where did the x squared come from?
X times x, the area of the bottom of the box. X times x would give me the area of the bottom. See that?
Yeah.
So good? Yeah. Okay, anybody else? Okay, so I got my two equations, one for volume, one for surface area. My goal is to find the smallest surface area, or the minimum surface area. Well, you don't want to just start plugging in numbers for x and h and hope you get the smallest number possible for surface area, okay, and still have it meet the volume requirements. So here's what we're going to do. We're going to graph this equation and find the minimum. Remember doing that a couple chapters ago where you calculated the minimum on your graphing calculator, left bound, right bound, that sort of thing? You found the minimum, the bottom. Okay? So that's what we're going to do. We're going to graph the surface area and find the minimum. Well, kind of tough to graph something when it's got two variables in it. Okay? So, here's what I'm going to do. They told me the volume was 184. So I'm going to put 184 in for the volume. 184 equals x squared h. Because they told me the volume was 184, so I put 184 in for the volume. Solve for h. Get h by itself. Do what to both sides? No, you're just getting h by itself. It's h times x squared equals 184. Divide by x squared. So h equals 184 over x squared. H equals 184 over x squared. Now what am I going to do with this 184 over x squared?
Plug in for h.
Plug it in for h. So surface area equals 2x squared plus 4x times 184 over x squared. All I do is take what h is equal to and substitute it in for h, because now I only have one variable. Now I only have x's in my equation. So now I can graph this equation on a graphing calculator and find the minimum.
I'm not sure.
Okay?
That's it.
Yeah. So, go to y equals, type in your equation, 2x squared plus 4x, and then 184 over x squared. Little FYI, you will probably want to put the x squared in its own set of parentheses, a lot of you, because if you don't, what it'll do is it'll take 184, divide it by x, and then square it. Okay? So you might want to put the 180 or the x squared in its own set of parentheses in the denominator. So all you do is you type in your equation, press enter. You'll probably want to adjust your window. If you think about it, remember, x represents the length of this side of the box. I'm betting it's smaller than 20, and I'm betting it's not negative, so I'm going to go 0 to 20 on my x window. 0 to 20 on my x window. Okay? I'm just thinking ahead. I'm changing my window before I draw the graph. Will you ever have to deal with negative numbers in a problem like this? No. No, it's not realistic. Y represents what? Surface area. Probably a pretty good chance that y is a big number. So I made my window be 500. Probably don't need to go that high, but I did because I don't want to have to guess a whole bunch of times in a row. Some people guess 20, and then 30, and then 40, and then 50, and they guess about 16 times before they finally get a big enough window, or they usually quit because they hate guessing too many times. Well, then just guess a big number. All right? Guess a big number. So I went 0 to 20, 0 to 500. There's my graph. To calculate the minimum, you go second, calculate. Okay? Second, trace, which is calculate. This screen shows up. You want your minimum, number 3. Left bound, so you move your cursor just a little bit left of where the minimum is, press enter. Then you move your cursor a little bit to the right of where the minimum is, press enter. Then move it back a little bit closer to the minimum, press enter one more time, and it'll give you the coordinate of the minimum. What does the x value represent again in our picture? X was what? Look at your picture. X was the length of one of the dimensions of the bottom of the box. So we want the bottom of the box to be 5 by 7 by 5 by 7. And then what did y represent in our equation? The surface area, so there's our surface area. Okay? So therefore I know then that x has to be about 5.7 inches, and my surface area was about 194.1 inches squared, right? I remember those numbers right?
Yeah. Okay, something weird.
Okay. Your equation must be wrong. You have x squared squared.
Oh, 5.3.
Okay? So that means these should both be 5.7. My surface area is this much. If you want to find out what h is, what could you do? Plug in right here, right? Because isn't h equal to 184 divided by x squared? So you can plug 5.7 in for x, square it, take 184 divided by that answer. You'll actually, anytime you want to minimize something, what you really should do is make all the dimensions the same. What will happen is the height also ends up being 5.7. You make a cube is what happens. Okay? But what I'm asking for on the test is I want to know the x value and I want to know the surface area. So those are the two things that you'll pull straight from your graphing calculator to get your answer. Okay? So that's the story problem in a nutshell.